Now you get to try out everything you've learned about acids and bases and their concentrations. So here's a problem for you to try. It's asking you what is the proton concentration, the hydroxide concentration, and pH of a 2 times 10 to the minus 5 molar solution of hydrobromic acid. So what you need to do is pause the video, do the problem, and then restart it to check your answer. So what is the proton concentration, hydroxide concentration, and pH of a 2.6 times 10 to the minus 5 molar solution of hydrobromic acid? I first need to write down my dissociation equation so I know what ions are in solution. Hydrobromic acid is going to give me a proton and a bromide. My proton and bromide concentrations are 2.6 times 10 to the minus 5 molar. So that means I can now say that I know my proton concentration. To get my hydroxide concentration, to use this equation, proton concentration times hydroxide concentration is 1 times 10 to the minus 14. I can rearrange this equation to determine my pH. I take my negative log of proton concentration. Now there's two numbers there, 2.6 times 10 to the minus 5 and 3.85 times 10 to the minus 10. Which one is the one that you would use to take your pH? Well, you have to remember that you're taking pH, not POH, so you look at proton concentration. So I must put the 2.6 times 10 to the minus 5 into my formula. So I take the negative log of 2.6 times 10 to the minus 5, and that gives me a pH of 4.59. Here's another problem for you to try. Determine the proton concentration and hydroxide concentration of a 1 molar solution of sodium chloride. Well, you might think this is tricky, but it's not. I'm trying to get you to think about what is in solution. If you look at this problem, it is a solution of sodium chloride. Sodium chloride will not change your proton concentration nor hydroxide concentration from pure water. So this is pure water with sodium chloride floating around in it, no excess protons, no excess hydroxide. That means everything's going to be the same, at least with regards to proton concentration, hydroxide concentration, and pH. That's all going to be the same as pure water. In pure water, your hydronium ion concentration is 10 to the minus 7, your hydroxide concentration is 10 to the minus 7, and your pH is 7. So again, here's another one for you. What is the proton concentration and the hydroxide concentration and pH of a 3.5 times 10 to the minus 4 molar solution of methanol? Stop, do this problem, and check your answer when. Now, we've talked about bases, and I told you that metal hydroxides were bases. But if you look at this, this is not a metal hydroxide. It's all nonmetals in the front. So this cannot possibly be a metal hydroxide, nor is it an acid. You don't see the hydrogen written first. So if I add methanol to water, I'm not adding protons nor hydroxide. So the proton concentration, hydroxide concentration, and pH is all going to be the same as if it were pure water. So hydronium ion concentration is 10 to the minus 7 molar, hydroxide concentration is 10 to the minus 7 molar, and your pH is 7. What happens to pH, proton concentration, and hydroxide concentration when you add magnesium hydroxide to a sodium carbonate solution? Try this problem and then check your answer when you're through. To do this problem, you have to realize that you may have sodium carbonate there, and that sounds complicated, but you have to look at what your action is. Your action is that you're adding magnesium hydroxide. That means you're adding a base, because magnesium hydroxide is a metal hydroxide. Base is going to add hydroxide. That increases the hydroxide concentration, and it must decrease proton concentration then. And then, of course, if your proton concentration is decreasing, your pH will increase. What happens to your pH, proton concentration, and hydroxide concentration when you drink Coke? Remember that Coke contains both carbonic and phosphoric acid. So try to figure out what happens to those things when you add Coke to your mouth. When you add Coke to your mouth, you're adding acid, so that means you're adding protons to your mouth. That decreases hydroxide concentration, and your pH will also decrease. What is the proton concentration, the hydroxide concentration, and pH of a 1 times 10 to the minus 3 molar solution of calcium hydroxide? Go ahead and determine these things and calculate what all of these concentrations are. To do this problem, the first thing you need to do is write the dissociation equation so you know what species are being formed in water. When you add calcium hydroxide to water, it forms calcium ions and 2 hydroxide. Because you have a positive charge on calcium, there are 2 hydroxides to accompany it. This means that if you have a 0.001 molar solution of calcium hydroxide, that the calcium concentration is 0.001 and the hydroxide concentration is 0.002. Figure out what my proton concentration is by using proton concentration times hydroxide concentration is 1 times 10 to the minus 4. And I can rearrange that equation to give me that proton concentration is 1 times 10 to the minus 14 divided by hydroxide concentration. If I plug in my value, I'll find out that 1 times 10 to the minus 14 divided by 0.002 is 5 times 10 to the minus 12. From this, I have my hydroxide and my proton concentration. The only thing I have left to get is my pH. To get my pH, I'm going to use pH is equal to negative log of proton concentration. So I look at my numbers and I determine which one of those is my proton concentration. And I see that my proton concentration is 5 times 10 to the minus 12. So I take the negative log of 5 times 10 to the minus 12, and that gives me 11.3. We're now going to look at acid-base neutralization reactions. When an acid and a base react, they form a salt in water. What we have here is a typical reaction of an acid and a base, and we can see that hydrochloric acid will react with sodium hydroxide to form sodium chloride and water. Now, typically, sodium chloride is called salt by everyone, but chemists call it table salt because we define a salt as anything that is the product of an acid-base neutralization reaction. Typically, salts are metals with nonmetals because metal hydroxide bases will react with protons that are attached to nonmetals, those are acids, and they give us a metal with a nonmetal, a salt. So salts really are anything that can be a metal with a nonmetal. There's a lot of different acid-base neutralization reactions. You can have phosphoric acid reacting with sodium hydroxide to make sodium phosphate, which is considered to be a salt. You can have hydrochloric acid reacting with calcium hydroxide to make calcium chloride and water. Calcium chloride is considered a salt.